Every year, more than 200 million smart TVs are sold worldwide. This means that every second, more than 6 new devices are turned on somewhere on the planet. With a market valued at over $200 billion, these smart TVs have become the center of entertainment in most homes. But do you know how they are made? In this video, see all the stages of smart TV manufacturing, from the complex electronic components to the final assembly and packaging. The manufacturing process of a smart TV doesn't start in a single factory. In fact, no TV company manufactures all of its own components. What we know as the manufacturer is actually a master integrator and assembler. The journey begins months or even years earlier with a vast and complex global supply chain. The microchips, the brain of the device, can be designed in the United States and manufactured in Taiwan. The display panel, the most expensive and crucial part, may come from South Korea or China. The plastic for the casing may come from a petrochemical complex in Europe. Hundreds of suppliers from dozens of countries send their products, from the smallest capacitor to the largest sheet of glass, to a central point, the final assembly factory. The most vital and most complex component to manufacture is the display panel. This is where most of the innovation and cost lies. There are mainly two types of technology on the market: LCD and OLED. For LCD panels, or liquid crystal displays, the process is similar to making a high-tech sandwich. It all starts in an environment that looks like something out of science fiction: the clean room. These rooms have their air filtered thousands of times per hour because a single dust particle, smaller than a human cell, can create a dead pixel and ruin an entire panel. Workers wear special suits, similar to those of astronauts, to avoid contaminating the environment. The LCD panel itself is a stack of layers. At the back, there's the backlight unit. In the past, they were fluorescent lamps, but today they're rows of LEDs. This light needs to be uniform, so diffuser and prismatic sheets are placed in front to spread the light across the entire screen. Next come 2 sheets of glass. The back sheet contains a grid of millions of thin film transistors. Each tiny transistor will control a subpixel. Between these 2 sheets of glass, a layer of liquid crystal is injected. The name is literal. It's a material that flows like a liquid, but whose molecules can be aligned like a crystal. In front of this layer, there's a color filter, which is a microscopic grid of red, green, and blue dots. Finally, polarizing sheets are applied to the front and back. In an OLED panel, each individual pixel is a tiny organic diode that creates its own light. When a pixel needs to be black, it simply turns off completely. This allows for perfect blacks and a contrast that LCD panels struggle to achieve. While the panels are manufactured in these specialized clean rooms, another vital part is being created in parallel: the brain of the TV. The motherboard or mainboard is what makes the TV smart. This is where the processor, RAM, storage for apps, and the operating system reside. Its manufacturing is an impressive example of automation. First, a machine applies solder paste, a sticky mixture of tin and flux, to each contact point. Next, the board moves on to the pick-and-place machine. This is the most frantic part of the line. High-speed robots with nozzles that move faster than the eye can follow. They pick up tiny electronic components, resistors, capacitors, chips from reels, and place them precisely onto the solder paste. A single board can have thousands of these components. It's on this board that the connectors we'll see on the back of the TV are also installed: the HDMI ports, USB, Ethernet, and the antenna. With the panel ready and the brain assembled, everything comes together on the final assembly line. The process starts with the back part of the TV casing, usually made of plastic or metal, being placed on the conveyor belt. At successive stations, workers and robots begin to fill that casing. At one point, the power supply is screwed into place. At another, the motherboard is carefully installed and connected. The speakers are mounted in their designated compartments. The Wi-Fi and Bluetooth modules are connected. Wires and flat cables are meticulously routed and secured to connect everything. The power supply to the motherboard to the speaker, and to the infrared receiver for the remote control. Then comes the most delicate moment of the assembly. The display panel, which is extremely fragile and accounts for a large part of the total cost of the TV, is brought to the line. Workers then secure the panel in place, connecting the panel's sensitive ribbon cables to the motherboard. Once the panel is secure, the front frame, or bezel, is snapped or screwed into place, sealing the unit. In just a few minutes, a set of separate parts has finally become something that looks like a television. But it's not smart yet. It's just hardware. The next step is crucial: programming and quality control. The TV is turned on for the first time on the production line. It is connected to a system that flashes the firmware and the operating system. Whether it's Android TV, Tizen, WebOS, or another one, this software is what gives the TV its interface, its apps, and its connectivity. Immediately after the software installation, rigorous testing begins. The TV is subjected to a battery of automated diagnostics. Test signals are sent to all the ports. Does the HDMI work? Does the USB port read data? Does the TV connect to the test Wi-Fi network? Do the speakers emit the correct tones? Color and image patterns are displayed on the screen so that cameras and sensors can check for dead pixels, color uniformity, and proper brightness. A significant percentage of the TVs, or sometimes all of them depending on the manufacturer's standards, are then taken to a burn-in room. In these rooms, the TVs are placed on racks and left on for several hours or even an entire day, often in environments with high temperatures. The goal is to stress the electronic components. The logic is that if a component is defective, it's more likely to fail in the first few hours of use. It's better if it fails at the factory than at the customer's home. Any unit that fails at any stage of this testing process is immediately removed from the line and sent to a repair station, where technicians diagnose and fix the problem. Those that pass all the tests receive the final seal of approval. They are then carefully packaged. Robots and workers place the TV on custom-made styrofoam or molded cardboard supports. The accessories, the remote control, batteries, power cable, table stand, often disassembled, and the user manual are added to the box. The outer cardboard box is folded around the set, sealed, labeled with a serial number and a barcode, and stacked on pallets. From the factory floor, these boxes are moved to a distribution center, loaded into containers, and shipped by ship, train, and truck, completing the final stage of their journey to the store shelf and eventually to the living room wall. And that was today's video. Remember to like and subscribe to the channel.